In this project, we use permanent magnet brushless DC motor, which is 24 watt, 12 volt, 2 ampere rating, designed for rotation of lower altitude wind. Our next source is solar panel of 10 watt, 17 volt, and 0.56 ampere rating. And then the third source can be biomass, which is optional. Next is two transformers of 12 volt, 1 ampere rating, a DC fan for wind sensing, 4 diodes for bridge rectifiers, LM555IC, LM741, LM7805, LM79112, LDR for light sensing. Then moving on to MSP430, which is 16-bit microcontroller for giving pulse to 555IC. In our block diagram, we consist of three modules. They are power production module, power enhancement module, and real-time monitoring module. Working of modules. The power production modules consist of three DC sources: the PV cells, wind turbines, and biomass. All three DC power sources are connected to the polarity controller to avoid the backflow of source current. Next, the charging circuit consists of a battery which is charged by a pulse charging technique to improve the life of the battery. The power enhancement module consists of maximum power plant tracking to improve the solar efficiency by detecting light from LDR. The real-time monitoring module is used to interface the production of power for maintenance and for future references. Let's move on to the working of the module. Our main circuit board consists of 6 input pins for DC sources. The positive terminals are connected to the bridge rectifier circuit and directly connected to the positive of the battery. But the negative terminals of the DC sources are not just connected to the batteries, else it is connected to the 555 ICs. The 555 ICs are connected to the inputs of MSP430. Small part of the output of 555 ICs are connected to the LM741 IC for amplification purpose, and it is connected to the real-time monitoring module for human interface. Explanation for charging module. The MSP430, which is connected to the third pin of 555 IC, gives pulse at very high frequency to produce pulse charging for every battery sources. So for first 4 milliseconds, the PV cell conducts the battery, and for next 4 seconds, the windmill conducts. Likewise, for next 4 seconds, biomass to conduct. By doing so, the life and efficiency of the battery increases twice the normal working of the battery. VB output graph. It shows the output of voltage produced by PV, wind and DC sources, and also its total voltage, and graphical notation for future interfacing and stored as a database. And this is the sample of our VB coding.